So today's topic is singly linked list. Before discussing singly linked list, first we'll discuss what is linked list. What is linked list? A linked list is a collection of nodes. Linked list is a collection of nodes. A collection of nodes we called as a linked list. What is linked list means? It is a collection of nodes. So a collection of nodes, a linked list is a collection of nodes which are connected sequentially. A linked list is a collection of nodes which are connected sequentially or linearly. A collection of nodes we called as a linked list. There are two types of linked lists. They are first one singly linked list. Second one, there are two types of linked list. First one is singly linked list. Second one is doubly linked list. Singly linked list and doubly linked list. What is singly linked list? What is singly linked list? Each node in a list contains only one pointer is called as a singly linked list. Only one pointer is called as singly linked list. Each node in a list contains only one pointer is called as singly linked list. What is a doubly linked list? Each node in a list contains two pointers is called as doubly linked list. Each node in a list contains two pointers is called as doubly linked list. Each node will contains one pointer is called as a single linked list. Each node contains two pointers is called as a doubly linked list. So we already know that what is node. So what is node? A node is a user defined data type which contains data and address. Here what is node? What is a node? A node is a user defined data type, which contains data and address of another node. So what is node? A node is a user defined data type which contains data as well as address of another node. That's we call as node. So what is the declaration of node? So what is the declaration of node? The declaration of node, what is the declaration? So class node. In the declaration of node, we say that class node int number, int number, another is called as node star next. So I use the pointer next instead of ptr. So I use the variable pointer next class node class node. So node is a user defined data type. This node will contains two data types, two data members. One is called as number, another is called as next, called as a pointer variable. A pointer variable which contains, instead of writing the pointer variable ptr, so I use next. Next is a variable of type node. This is the node declaration. For example, if you go for an example of node, if we take one example of singly linked list, what is a list? For example, this is the node. So each node, suppose this the address of the node. How we say that address. So this is the address, for example. The address of the, let us assume that the address of the first node is 1000. Let us assume. For example, this is the address of the first node. So suppose this is the address of the second node. Let us assume this is the address of the second node, 2000. This is the address of third node, 3000. This is the address of the fourth node, 4000. This is the address of the another node, 4000. So this is the, for example, so this is the first node. It contains the data 1. So it also contains the address 2000. One 2000. Suppose 2. So this is the this is called as node. So this is called as actually. So this 2000 indicates the address of the second node. So that's we can represent like this arrow. So this is the first node. First node we call as start. This is the first node. First node we call as a, I will call it as a start. So this is the node declaration. That's we called as single linked list. This we called as a node. So what is this? This is called as this we called as a node. This is called as node. So this is called as node. So this is also another node. So this is also another node. This is also another node. Like this we have different nodes. Each node, this is the address of the, let us assume that the address of the first node is 1000. The address of the second node is 2000. The address of the third node is 3000. The address of the fourth node is 4000. The first node, so we can store the address of the first node in a variable called as start or end, anything. Suppose here I will use variable node, variable start. So first node address is will be in start. So whatever the address of the second node, that address is stored in first node. The third node address is stored in second node. Fourth node address is stored in third node. So when we know the first node address, from first node we can traverse to second node. From second node to third node, because second node will contains the address of the third node. From third node to fourth node, because third node will contains the address of the fourth node. So we called as a last node. So when the address is null, that we called as a last node. When the address is null, so then we called as a last node. This is the last node. The first node can be identified by using start. When the first node is identified by start, first node will contains the address. First node address is in start. So from first node, the first node will contains the address of the second node. So from first node to we can traverse to second. The second node will contains the address of the third node, so that we can traverse from second to third. The third node will contains the address of the fourth node, so we can traverse from third to fourth, like this. So this is the process we are using in linked list. This is the single linked list. So then what is the process? How to create a single linked list? So dynamically. So here we are using the process is called as dynamic approach. So we are not using the static approach, we are using the only dynamic approach. So by using dynamic approach, we can start the single linked list actually. So we can start dynamic approach only. So how to create? How to create? This is actually a theoretical process. From theoretical to how to create. How to create single linked list. How to create a single linked list? First, we have to allocate the storage dynamically. How to allocate the storage dynamically? So how we can allocate the storage dynamically? So by using the operator new, we can allocate the storage dynamically. By using new operator, we can allocate the storage dynamically. Temp equal to, suppose if I write like this, temp equal to new node, for example. If I write like this, temp equal to new node. So when I write like this, automatically the system will allocate the storage for the variable node and store the address to the variable temp. So this is the way to allocate the storage dynamically. How we can allocate the storage? Temp equal to new node. When you write like this, temp equal to new node, the system will allocate the storage dynamically and assign the value to the variable temp. So first we have to allocate the storage. After allocation of the storage, then you have to check it whether the list is already exist or not. After allocation of the storage, you have to check whether the list is already exist or not. So if the list is not exist, so how you can find it? After after allocation of the storage, first we have to check whether the list is exist or not. How we can find it? The way find. So check. Check whether the list is whether the list is exist or not. Check whether the list is exist or not. So I will check it if start equal to null. The list is empty. The list is empty when start is null. The list is empty when start equal to null. So when if the list is empty, and the list is empty, assign to first start. Assign to start node. So first we have to check whether the list is empty or not. So if the list is empty, so then whenever the list is empty, so when the list is empty, so you have to assign to start. If the list is not empty, no need actually. If the list is empty, assign to start. Then okay. Third, if the list is not empty, so if it is store the address of this node into previous node. This node into this node. The list is not empty. So if the list is empty, you have to assign to first node. If the list is not empty, then store the address of this node, into previous node. You have to store the address of this node into previous node. If it is a last node, so make the address is null. So this is the process we are using to create a single linkage. First, you have to allocate the storage. How we can allocate the storage? Temp equal to new node. By using the variable temp equal to new node, we can allocate the storage dynamically. After allocation of the storage dynamically, so then you have to enter the value. Then after allocation, enter the value. After allocation, allocate the storage dynamically, enter the value. So temp equal to new node. So when we write like this, temp equal to new node, the system will allocate the storage dynamically and then access. So check whether the list is exist or not. So you have to check it. So the list is empty when start is null. So when the empty is so when the list is empty, assign to start. Okay. If the list is not empty, so if it is not empty, assign the address of this node to previous node. So if it is a last node, you have to make it as a null. So if it is a last node, you have to make it as a null. This is the process we are using for a creation of a single linkage. Once we can create, so then how to traverse. So this is the way of creation of single linked list. Once we can create a single linked list, then we can traverse the list. How to traverse the list or how to display the list. So how to traverse the list, how to display the list. If the start is null, list is empty. Otherwise, assign the value to one variable and from beginning to end, so we can traverse the list. So we know, so how to traverse. We already know that the address of the first node is always stored in the variable start. So from start, you have to check it whether the address is empty or not. So from this, we can traverse the next node. From this to we have to traverse. The first node will contain the address of the second node. So we can traverse to second node. The address of the second node will contain the address of third node, so that we can traverse to third node. The third node will contain the address of the fourth node, so that we can traverse the fourth node. Like this, we can traverse until the list is empty. This is the process we are using for creation of single linked list and traverse the linked list. So we can traverse the list, start from first node. Start from first node. So check if it is null or not. Check if it is null or not. If it is not null, print the value, traverse. So this is the process we can use. So check, start from first node, check if it is null or not. If it is not null, so if it is not null, print the value and traverse the next node. This like this we can process until to find the node. This is the way we are using to creation and traverse the single linked list. Then we go for how to implement such a single linked list in C++. So implementation, then we go for implementation of single linked lists. Okay. So we go for hash include stdio. Sir, I know we can't take stdio as iostream.h. Hash include onio.h. First, we have to declare the class node. How to declare the node? Class node. Node has two members, int number, node star next. Next is a pointer variable which contains address of the another. This is the node. Then we go for class. Then we go for class. Class SLL. I will use the name SLL, singly linked list. Node, I use some variables. Node star temp, star current, star star. These are the variables. I will take three objects: temp, current, and start. First, I will make start as a null. So I will make a start is a null. So public, we use the constructor. So I use the constructor. What is constructor? Constructor is same as class name. So it has no return type. This constructor will be executed automatically whenever an object is created, which is already covered in C++, I think. So it is a constructor. I am using the constructor. SLL is a constructor. So what is constructor? We know that constructor. What is constructor? Constructor is same as class name. So we already know that. So constructor is a special member function which is same as the name of this member function is same as class name. The constructors are invoked automatically whenever an object is created. So here I make a start equal to null. It's a capital. Then I will use some functions. So void create. This is one function. Void display. I use two functions. One is create, another is display. These are the two functions I am using for create linked list. Later we can add one by one function, no problem. So this is the function. So create and display. Create function is used to create a single linked list, and the display function is used to display the linked list. First we go for how to create a single linked list. Void SLL create. How to declare the member functions outside the class? So return type, class name, scope resolution operator, and function name. This is the way. So char ch char ch do. First you have to allocate the storage dynamically. How to allocate the storage dynamically? Temp equal to new node. So when we write like this, temp equal to new node, the system will allocate the storage dynamically for the variable node. After that, you have to enter value cout. Enter a number. And then seen here. This is the number. Enter a number. So this is the first point. I already told in theory. So we have to allocate the storage and enter the value. So how to allocate the storage dynamically? So temp equal to new node. After that you have to enter a value. Cin. So what is the variable? So here we are using NUM. So here I am using NUM. Cin NUM. So NUM. So after sorry, not like this. Temp arrow NUM. So object dot. So we cannot access the members directly. So we are using object dot. So whenever you are using a pointer type, I am using pointers to pointers. It is a pointer to what is the pointer to member access operator? Arrow is the pointer to member access operator. So see temp arrow number. So after this, check it. If start equal to null. If start equal to null, we make it as a start. Start equal to temp. Current equal. So I will assign also store this address to another variable called as temp. Current. So when start equal to null, so I will make this node as a first node. Then start equal to temp and the current equal to temp also. Else. If start is not null, that means if the list is already existed. So if the list is already existed, the address of the previous node is stored in CURL here. So when suppose if it is the first node, the address of the first node is stored in start as well as current. When you go for second node, so the address of the first node is in start and CURL. So I can't change the start, so that I use the current. So current arrow dot next equal to temp. So what is the meaning of this? The address of this node is stored in the previous node. That previous node I will call as current. So in current node there are two fields, number and next field. So I will store the address in next field, curr dot next. So when curr dot next is equal to temp indicates store the address of this node into the previous node current. So in the field next, then I will make it as current equal to temp. This is the way. Printf. So cout. Do you want enter another node? Do you want to enter another node while ch not equal to e? You want to enter another node while ch not equal to n. So this is the process. Finally, we'll make it as temp arrow last node address temp arrow next equal to null. Finally, so I want this is the way to create. So I already told that first of all you have to allocate the storage. How we can allocate the storage? By using the variable temp equal to new node. Whenever we are using the temp equal to new node, the system will allocate the storage dynamically. After allocation of the storage dynamically, then you can enter the value. So how we can enter the value? So by using the variable cin. So we know that the node is a temp. So temp. So the node will contains two fields, number field and next field. So where we want to store the number value in number field, that's way temp arrow number, temp arrow number. So where arrow means pointer to member access operator. That's why we see in the temp arrow number. So that is the first point. After that, check whether the list is empty or not. How we will check whether the list is empty or not? If start equal to null indicates the list is empty, otherwise the list is not empty. So first we have to check it whether start equal to null or not. If start equal to null indicates the list is empty, there is no existing list. In this case, so we have to assign the address of this node to start. So that's why start equal to temp. When I write like this start equal to temp, the address of the temp node is also stored in start. And I can also write in curr equal to temp. So the address of the temp is also stored in curr, because that means the first node address is stored in start as well as current. For example, if the list is already existed, suppose this is the second node. So if it is a second node, start equal to null? No. So this is the second node. So second node means the address of the second node means the address of the node is temp. Store this address into the previous node. So in how we can identify previous node? By using curr. Start is there. So start indicates always the first node. Curr is the previous node. So curr. So this is the node. Curr is the node. In node we have two fields, number and next field. So where to store next? Curr next equal to temp. Then you have to use curr equal to temp. Again I make it as a previous node. That's why curr equal to temp. So do you want to enter another node cin equal to ch? While ch not equal to null. Suppose if you give yes, you want another node. If you want no, so you have to give n. So whenever you will give the n, there is no need of next nodes. Then finally you make the address is null. This is the create. Then we go for void display. Void SLL colon display. Void colon SLL display. So in display, we can display the linked list. So how we say that if start equal to null, if start equal to null, list is empty. Else current equal to start. While start not equal to null, sorry, while, so I will make it as current, while current not equal to null. Current not equal to null. So we already indicate that finally null. Cout. What we want to display number, curr number. Cout curr number. Current equal to current arrow. We go for next node. This is the way. This is the reference. So we go for main, void main. SLL. So I'll create a non-object S1. S1 dot start. S1 dot display. node number is not accessible, node next is not accessible. Node number, node next. Number is not a member. Yes, NUM. SSL start is not accessible. SLL not start, create. So enter a number, suppose 4. Do you want to enter another node? Yes, 5. Do you want to enter another node? 6. Enter another node? No. So this is the 4, 5, 6. The list is what we are given values 4, 5, 6. So this is the way we are get the single linked list. This is the process. So to get the single list, this is the way of creation and display of single linked list. So first of all, see, first you have to declare the node. So how to declare the what is a node? A node is a user defined data type which contains data and address. So what is data? So it is a number in the data, and address I will use the pointer variable next. The access specifier of these two is the public, because when you define member as a public, then only it can be accessed anywhere in the program, otherwise it cannot be accessed. That's why I define this. After that, I go for implementation of SLL, singly linked list. So I will use 3 objects, node, current and start. These are the 3 of type node. So first I will make it as start is null. How to make the start is null? So how will make start is null? So by using constructor. How you can write the constructor? So which is same as a constructor is a special member function which is same as a class name. So what is the class name? SLL start equal to null. So when we use that like this, so then start equal to null is, then we are initially the start. I can use 2 functions. One is called as create, another is called as display. So what is create? So create function is used to create a single linked list, and display function is used to display the linked list. So how to create a single linked list? So how to create a single linked list? First you have to allocate the storage dynamically and then enter the value. So first how we can allocate the storage dynamically? Temp equal to new node. So new the dynamic memory allocation operator in C++. Temp equal to new node. When you write like this, temp equal to new node, the system will allocate the storage. Then you have to enter the values in temp arrow number. After that, check it whether it is whether the list is already exist or not. How will you find whether the list is already exist or not? If start equal to null indicates the list is empty, otherwise the list is not empty. If start equal to null indicates the list is empty. So that assign the first node address to the variable temp, and I will make it as a current also. If it is not first node, so it is a second node. So you have to store the address of this second node into the previous node. We already know that the previous node is current. So current arrow next equal to temp, current equal to temp. So the address of this node is stored in previous node. Previous is current. Current has 2 fields, number and next. So you have to store the address in the variable next. Yes. Again I'll make it as a previous node. Current equal to temp. Do you want to enter another node? Say yes or no. If yes, again we will go for another node. This process is continued until do you want to enter nodes? Finally, we make it as temp arrow next equal to null. So that means the address of the last node. I already told that in diagram. The address of the last node is always null. That's why temp arrow next equal to null. Then I want to display the nodes. So if start equal to null, list is empty. Otherwise, we can print the list. So we can write also. So you have to print the list from the beginning. That's why current equal start. while current not equal to null, so we have to print the number, go for next node. So we could to go for next node, current, so we already know that the each node address field will contain the address. So current arrow next, first node address is assigned to, again we go for next node like this. So finally we print the lists. Enter in the first number 1. Yes. Do you want enter? Yes. Enter second number 2. Yes. 3. Yes. 4. So finally I don't want n. So this is the list 1, 2, 3, 4 line. This is the way to get the single linked list. This is the final. So this is the way to create and display of single linked lists. So this is the list is 1, 2, 3, 4. So this is the way to create the single linked lists. Okay, this is about creation and the display of single linked lists. So I request the questions. I request the response from the students. Do you understand the concept or not? So can I explain once again, or you understand or not? Students can chart them, because it's one somewhat difficult work. So if you understand the concept, no, I will go for next continuation functions. Otherwise, I'll explain once again tomorrow also. So students can respond. 528 is one responded. 94. Okay. Understand. Okay. 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 Nice. Nice. Okay. So I think everybody is understand. Hmm? Okay, tomorrow I will discuss some more functions using single linked list. So do you have any doubts? You have to chart them. So I will clarify your doubts. So before